Today I've been looking at paper folding, and in particular this, which is the Miura fold, because there are links between this type of folded paper and unfurling solar panels on satellites. I looked into doing it and I actually made one of these folds. It's a bit tricky, but this piece of paper, you pull it from two opposite corners and it should unfold into one flat sheet like a big solar panel. And actually I think they use this kind of technique in maps as well. Some of those little city maps you can get them that sort of fold up a bit like this as well. But then I saw this video and I thought that looked pretty cool, so I thought I'd have a go at making that. I thought, well, I wonder if it works with just plain A4. So I had a go. I got a sheet of A4. It's actually an old orienteering map. So I folded these lines at what looked like a suitable angle, and it was nowhere near any good. Okay, because you ended up with this bit flapping in the middle, which wasn't right. And I did realise that actually the size, the dimensions actually mattered. So what I did is I drew it out, and I could see that this length here basically had to be the same as that length there, and also that these two angles, so this angle here and this angle here, had to be the same as well. And just by kind of looking at it, so if that length and this length and that length are all the same and these two angles are the same, then what we end up with is this big triangle pretty much must be an equilateral triangle. Something where actually we have two equilateral triangles like that, one here and one there, and those are all 60 degrees. Okay, and it also had to be divided into three equal parts. That's clearly not equal, but that would have. So what I thought I'd do is I'd measure it up, and I thought at this length here I'm going to make the length of an A4 piece of paper, which I looked up and was 297 millimeters. A third of that actually worked out to be 99. So each of these middle folds had to be 99 millimeters. So this triangle here has to be a 30-degree triangle here. This bit has to be 99, so we can work out what this distance across has to be, because if I label it x, 99 over x, which is opposite over adjacent, is tan of 30. Okay, so x must be 99 over tan 30 degrees, 171 millimeters. So that has to be 171 millimeters across there. We also need to know where is this point going to be where we have to do our folds. So we have to do a fold here and here, and this angle here has to be 30 degrees as well. So that was x, was the whole lot here. So let's make this one y. So in this case, y over 99 equals tan of 30. Okay, so that means that y is 99 tan 30, which is 57. So this length has to be 57, this length has to be 171, and then there would be the equivalent ones over here as well. And 171 is less than the width of the paper. The width of the paper is something like 210 millimeters. So I had to cut out a sheet of paper, and this is what it looked like. So it was 171 there, it was 57 here, 57 here. What you then have to do is fold it into the three pieces. Okay, so it's folded like that. Then you have to get your angles, the diagonals folded as well. So that fold there, and then this one has to fold diagonally there as well. Okay, so those two diagonals are folded. What we then do is we open up one end of it and we keep the other end folded, and this should be 57, but it also needs to kind of match with this line here. So when we fold this across, this bit should be running along the centre line, and this part should be matching up with the edge of the paper here. So that part folds across like that, and we have to fold it backwards and forwards, because we're going to need to fold it a different way. And then we do the same with the other fold here. So this one has to match up down the centre line, and it also has to match up down the centre line here. The closer you can get it to the centre line and the edges, the better, because everything lines up neatly. Once it's unfolded, we then have to rearrange the folds, because this one has to fold upwards. Okay, so that one folds upwards like that, and then this one has to fold downwards. So this is why you have to crease these in both directions so that it will actually fold the right way. So that folds downwards, this one folds upwards, and then we basically close it all up like that, and that's your, well, in the diagram, in the video, it was a little invitation, and this one you can unfold it like that. It's the right size to put inside an envelope. You can write your party invitation on the front, and then you open it up and it's got all the details. I just thought it was interesting, and I thought it was quite a nice mathematical challenge to work out all the sizes.